maybe we can go ahead and introduce ourselves as co-moderators of the session. So I'll go ahead and start. So it's such a great pleasure for me to be here. My name is Rinku Roy Chowdhury. I'm a professor of geography here at Clark University. And I work in the field of land system science, which is basically and contribute basically to the Global Land Program, which is an international scientific program on the study of land use and land cover change, of which I was co-chair for a number of years. My work integrates remote sensing and Earth observation data with field ecological measurements and social science, such as surveys, to develop quantitative coupled natural human systems models of land systems, land change, and resilience to various perturbations. I have in-depth work that I do in multiple geographic regions, including currently agroecological landscapes in Mexico and Latin America, urban ecosystems across multiple US cities, and broadly speaking, questions of climate vulnerability, landscape epidemiology, and environmental governance. So great pleasure to be here. I'm very, very excited to learn from the folks in this breakout room about their work and about sort of cutting edge tech interventions in this space. So I want to invite my co-moderator to introduce herself, Jane Ramirez.
Thank you, Rinku. I'm very honored to be here. I am Jane Pauline Ramirez, and I am a PhD researcher in Delft University of Technology under the Biomorphic Intelligence Laboratory. So I'm currently researching on a biomorphic drone for multimodal locomotion. So drones that not only fly, but also walk on the ground or roll on the ground. And my previous background was on bionics engineering in Italy and mechanical engineering in the Philippines. And my research interests are on embodied intelligence, bio-inspired designs, and aerial physical interaction. So I'm very happy to welcome you all in this breakup session. And I hope we will all enjoy our conversations. Really happy to be here. Thank you. And let's now proceed on calling on our speakers for today. Let's start to call to Miss Lelyana Midora to introduce herself.
Yes, thank you, Jane. Nice to meet you here. I'm Lelyana. Yeah, I'm speaking from Switzerland here, and nice to meet you all here. It is an honor for me to be speaking in this summit, and also special thanks to Patrick for inviting me. And I don't feel like I am an expert in this field because I have background in conservation and not in robotics. But anyway, I'm here today, happy to join you all to especially learn interesting and new insight and knowledge and experience from you. And I will do my best to share my experience with you from my side, and I hope it will bring something useful too. So my educational background is in forest resource conservation and natural resource management using GIS and remote sensing. So I have various work experience in different sectors, from conservation NGO and private sector in technology for gas and oil pumps, inspections, also some consultancy services. And my currently my role at Inverto Earth is to coordinate project and establish a partnership for coastal ecosystem restoration, focusing on mangrove. And currently we are operating in Indonesia. And why Indonesia? Because as an island nation, is particularly vulnerable to sea level rise. So we are in the pilot project right now, testing our drone planting and monitoring technology in the field. Also doing some experiment in the laboratory to test different species of mangrove with our innovative biodegradable planting 3D medium. And we launched them into the field and monitor the growth over time before they are ready to be planted in the degraded lands. We are also planning to work with local conservation NGO to work on identifying biodiversity of mangrove using their local knowledge, combined with some literature studies to produce local biodiversity inventory booklet. So why what specific climate change are we working on right now? We are dealing with sea level rise, coastal erosion, land subsidence, carbon emission, pollution, and biodiversity loss. And why is this a climate priority for us? This is a priority for a number of reasons. Firstly, mangroves store a lot of carbon, 4 times more than terrestrial forests. Secondly, mangrove are sanctuaries for biodiversity, including marine and terrestrial species due to its location between the sea and the land. Thirdly, mangrove improve water quality by filtering out pollutants. As such, by protecting and restoring mangrove, we are addressing all three planetary crises, which are climate change, biodiversity loss, and pollution all at once. And it is also priority because it is protecting people's land and livelihood from flooding, for example. So also restoring and conserving marine resources. So as we know, climate change give real impact and influence on the global economy and sustainability of natural resources, leading to water and food scarcity and so on. So this is why it is priority for us. And what are we doing to overcome this challenge? We are doing mangrove restoration project, as I said earlier, using combination of innovative technology, drones, and local knowledge and local participation. The drone for accelerating the restoration only use when it is necessary, when areas are difficult to reach or dangerous for people to walk in, also to save time when laborers are not available. So apart from the drone planting, we are also developing drone for monitoring to enable eDNA data collection from water sample to understand the biodiversity in the ecosystem. So we are not only using technology to scale the restoration of ecosystem with our drone planting, but we are bringing also additional transparency to monitor restoration progress and impact on the ground to avoid greenwashing as discussed earlier. So we bring a holistic approach, partnering with research institutions and local stakeholders to make sure the restoration is following the conservation principles, including the biodiversity value. So we are not planting only one species of mangrove or monoculture, but we diversify the species too. So we are bridging the investors and corporations to contribute, bringing nature positive impacts on the ground through mangrove restoration and help to monitor the progress. So yeah, we are trying to facilitate the ESG investment in areas where they can achieve the biggest impact by measuring and collecting data to measure the impact on biodiversity, carbon, and social. So I guess this is from me right now. I hope it is useful. So I give the floor back to the moderator. Thank you.
Thank you so much for that introduction, Ms. Lelyana. That is so interesting. Planting mangroves using drones and assessing impact using drone data collection. This is really effective for helping the biodiversity. Let's move on to our next speaker, Mr. Maximilian Isensee from Wind Energy Generation, to introduce himself, please.
Yeah, hi everybody. Thanks for having me. I'm Max Isensee. I'm one of the co-founders of KiteKraft. And we basically are trying to invent a new type of wind turbine. For everybody to have a look how that looks like. I just posted a link here in the chat of one of our prototypes actually flying. So what we do basically is we use a combination of drone technologies and sophisticated software to basically replace a conventional wind turbine. Because if you look at a wind turbine from a first principles perspective, most of the energy is actually captured by the most outer parts of the wings that sweep the largest area and by that contribute most to the actual energy generation. And that is good and fine, but in turn, basically a lot of the materials of the turbine are kind of support structures to get to these capturing these large areas of wind energy. And so we're basically getting rid of all this. So these large towers, these huge blades, to have a system that is really small, flies in high altitudes, and is only connected via a small tether to a fixed ground station. And then we have it fly in a pattern of figure eights, just like a kite, a recreational kite could do. That's also why it's KiteKraft. And yeah, with that, we basically have a system that does the same thing in the end, produce renewable energies from the wind, but saves 90 to 95% of the materials while still producing roughly the same amount of power. And that is obviously a big benefit to bring down costs for wind power. And with that, we're making it much more viable for more applications as well. So conventional wind turbines today, you hardly only find them in like very big wind parks. So the smallest wind turbine that you get today is kind of starting at like 1.5, 2 megawatts. And then basically nobody builds a single wind turbine. So you always go for a park and then you're already at like 10 megawatts already. So there's a lot of room in our opinion to bring wind power to much more decentralized use cases where it's currently not really economically viable, to make it useful there. And that's where we're starting, building from a 100 kilowatt system, but eventually wanting to scale it to a megawatt sized single turbine where we then have the similar power production as a conventional wind turbine today. Starting onshore, eventually we will do this offshore. But that's down the road. Obviously, co-benefits of all this is that we have a system that is much less visible because, again, it's a much smaller system, so there's much less stuff in the air than when you're having a wind turbine sitting there, and it's only actually visible in the air when we're producing energy. When not, the system just lands on the ground station, and with that, basically the visual impact is gone at the site. So this is a big issue in the project development of wind farms, that you have a lot of public opposition due to the visibility and some other aspects. So this is something that we want to contribute on as well. I showed the video of the prototype. That's what we have right now. We're currently transitioning from that system, testing a little bit more, but preparing the upscaling to the first product size. We actually this week got a permit from the German Federal Airspace Authorities, and then another big win that happened last week. Airborne wind energy as a technology is recognized now in the German EEG law, so the Renewable Energies Law, and will now get a guaranteed fixed feed-in tariff, as wind or solar did in the very beginning in the 90s, 80s. So that's something that definitely helps in de-risking this whole space a lot and making it much more viable for other type of financing providers like banks or infrastructure investors. So yeah, I think that's it for now. Happy to dive deeper into this discussion.
Thank you so much, Max. That is quite interesting. So from micro materials, saving a lot of materials, to renewable energy, to like in a macro scale, right? And now having finance and laws inch by inch going to that side as well. It's very helpful. Thank you so much. Let's proceed to our next speaker, Miss Elizabeth Hunter, for monitoring land assets. Please introduce yourself. Thank you.
Thanks, Jane. Hi, everyone. I'm Elizabeth Hunter. Very excited to be here today to take part just in these critical conversations on the intersection of robotics and climate. I'm based in the United States, kind of calling in from Philadelphia. And just a little bit of background before I tell you all about TreeSwift. I'm both a technologist and an entrepreneur. So I have a PhD in robotics from Penn's GRASP Lab, and then after my PhD, I spun out TreeSwift, my company, after completing my PhD work. And kind of my background, I've worked on a whole range of mobile robotics solutions, from drones, so at very kind of macro scales, to micro robots at very small scales as well. And I've always kind of worked in applications that focus on biological systems, natural environments, and especially sensing and information gathering in very hard to reach places. which is what really brought me to founding TreeSwift, which is the AI platform for forests. So at TreeSwift, we focus on bringing technology to landowners and managers that can really help these folks make critical forest management decisions in very proactive ways. So we work with timberland investment management organizations, large landowners, carbon project developers, and also utilities companies to really help them understand and manage their forests, vegetation, trees, and land. Forests cover about 30% of our planet. Our forests give us clean water, clean air. They're a source of these standing carbon stocks that are so critical in nature-based climate solutions. And really managing forests is really critical to proactively mitigating risks posed by a changing climate. And so at TreeSwift, we provide our customers with accurate and actionable forest inventory information. So what this looks like is stem level metrics about individual trees. So diameters of trees, heights of trees, really insights about the health of trees, if trees pose a significant kind of risk, or if they're dead, if they're dying, if they're diseased. Just kind of a range of insights about the trees on our customers' land. And we deploy our technology on the ground from beneath the canopy. So there's multiple different ways that you can gather information from forests. You can look from above. So I know we have a lot of remote sensing folks on this call. So from above, satellite, LiDAR. But one of the things that is really critical is that below canopy sources of information. And so we have developed a sensor suite that contains high resolution imagery and LiDAR that we deploy from beneath the canopy. We collect this information and then process those insights using our AI that we've developed, and then give that information to our customers in the form of forest inventories. I'll post a link in the chat here about what some of this actually looks like in deployment. Our sensors have been deployed on drones, on backpacks that people can wear, and then also on trucks and utility vehicles as well. So we've kind of taken a modular approach to the design of our technology. Forests are unstructured, wild, and messy environments, and oftentimes there's not a one-size-fits-all technology in order to gather and get the information that is required for managing the land. We primarily use our backpack-based system today, so we actually partner with local crews, local talent, and are actually working with local workforce to teach them how to use our backpack system so that they are equipped to take these measurements and to gather this information in concert. So we're working in concert with boots on the ground. And to date, our technology has been used so far across 500,000 acres. So we've provided forest inventories on 500,000 acres. We're primarily operating in the United States, but we have our first projects in Canada later this year. And so I think one of the really great opportunities that robotics poses in this space, especially at the intersection and kind of in this application in forestry, is really gathering, digesting, and disseminating this forest information at a scale and at a speed and an efficiency that's really unprecedented. The way that people typically get these measurements on forests today is by walking around with a tape measure and a clipboard. So this really, using robotics in concert with boots on the ground, really unlocks these kind of new scales, speeds, and efficiencies to get this most critical information to make really important land management decisions. And I'm excited to dive into more of this in the conversation today. So with that, I'll give the floor back to Jane.
Thank you so much. That is quite interesting, right? Forests are really important in our carbon goals and endeavors, and having our technology and drones and AI work together to get more information, to scale and minimize the labor in gathering this information is really essential to manage these land uses. Thank you so much, Miss Elizabeth. Last but not the least, our another speaker for today is Mr. Frank Kjerstein for erosion repair of wind turbines. I would like to ask to introduce yourself, please. Thank you.
Thank you, Jane. Yeah, my name is Frank. I'm one of the two founders of REBLADE. And the specific climate challenge that we're working on is somewhat in the realm of what you just introduced, Max, with KiteKraft and renewable energy. Because you have wind energy as a way and as a source to scale renewable energy in the green transition to meet the goals that we all know about in this room. And in order to reach these goals, there's focus on hydrogen, there's focus on solar, but the cheap and the proven and the scalable solution, when you have to do this at mass scale, you always end up looking at wind. And KiteKraft, you're solving one way of helping wind to keep growing in a way where you make it, as you just described, approachable in smaller amounts, and then scale that to kind of remedy the things that are not necessarily wrong, but are derivative effects with the way we do wind energy now. Being more specific on that, once you scale the current wind turbines, the big ones that you talked about, Max, you actually create problems that you didn't have with the smaller wind turbines. The destruction, the erosion, the damage, the wear and tear of wind turbine blades is much bigger, it's much faster and more outspoken on bigger turbines. And the main reasons being that big turbines can't really be over-dimensioned. In short, a wind turbine blade conceptually can be understood as having a protective layer like the enamel on your teeth, and then a structural integrity, that carries the blades. And once you erode the protective layer, you then start eating into the structural integrity of a blade, which you cannot have. So you have to go out and repair them. And not everybody is aware that wind turbine blades, they erode. This is a massive problem. And the more wind turbine blades we put out, the more wind turbines you have to maintain. And this is a specialized workforce called robotics access technicians. And they're already in critical demand. So the last 10 years, there hasn't really been any state-of-art innovation in this sector. I'm exaggerating a bit by saying, well, they have improved the harness that they hang in when they do these repairs. But the erosion has come down so that you need to repair it every 2 years instead of every 5 years because the turbines have gone bigger. So in a way, what we do with our drone is that we fly up instead of having people go up in ropes. And they use 4.5 days to repair blades, whereas a robot, an aerial robot, such as is the focus here, can do it in 4.5 hours. So in that way, we support the green transition about making, wind energy sustainable from a maintenance standpoint as well. In a way, the focus that's been on wind turbines about meeting the scale at which we need it has made some, I won't say it's compromises, but it's made some choices that were needed and obvious, and then you would solve the problems later. And it has made, if I exaggerate a bit, and has this, kind of hot take that you ask about as well, if I preface that a bit, it's making the blades of traditional wind turbines so that blades are becoming consumable in the way that we prioritize scaling wind. And we're there to take out the trash, we're there to fix the maintenance. So we look at the derivative effects of scaling wind. And we do that by flying a drone up that has automated the process that human workers do. so that we can support the scale. All right, that's basically it. Thank you, Jane. Back to you.
Thank you, Frank. That is, yes, sustainability is not just creating technology, but also maintenance and going after the life year of your technology, right? Wow, yeah. This is really a good conversation, because we see from, you know, creating technology to getting information, and then after the life cycle or within the maintenance cycle, what are we looking at? What are the challenges that we're looking at using drones and aerial robotics? Wow. So thank you so much for having our speakers today. I'm really grateful that you're here. And now I would like to call on Rinku for our first question for today's panel discussion.
Thanks so much, Jane. And thanks, everybody. That was just absolutely exciting and fascinating to hear the areas in which you're working and the specific application that you're, and R&D that you're involved in at the moment. I wanted to sort of bring us all back to maybe kind of considering a central question, which is, which concrete climate problems are you specifically prioritizing in your particular area of application in robotics? And in connection with that, when there's monitoring or other kinds of deployment, including the wind energy capture and so on involved, how will you measure baseline performance and then incremental impacts of the role of robotics in improving outcomes? So I open it up to really any and all of our presenters to reflect on that as they see fit. And then we'll go on to another couple of questions that we have for the group. And thank you, Kate, for the chat.
If nobody goes ahead, I maybe can just go and start. So yeah, for us, it's quite simple in the sense that we're targeting renewable energies. So we want to produce more energy from wind, and the main goal is basically, as you already said, Frank, to expand what wind power can do. So we are already fans of conventional wind turbines. We love to see more of them develop. We don't see that as a huge issue for us as a company. But we do see much more potential that is not being tapped into right now. And that's basically what we want to address at the beginning. So in terms of like actually measuring that, that's actually a more interesting question, how you look at it. Because for the early applications that we go for, picture putting a small wind turbine for rural industry sites, for small communities, or for microgrids. And those types of use cases, for the most part, they don't really have a wind power solution right now. So there, it's kind of an added renewable resource that we're trying to make available for them. At the same time, when we're talking about energy, there's a lot of other sources of energy that you could tap into, right? So there are other options that can be used, sometimes with a higher CO2 footprint, though, because for example, in microgrids, solar is becoming a very dominant factor here, but in those microgrids, you oftentimes still have diesel generation as the main backup, and in certain cases still as the main power source, actually, for most of the operation. And that is hopefully something where we then want to reduce the fuel consumption of diesel, replace it with wind, and make an impact there. And then once we scale that to a larger scale and have a impact on a grid level, hopefully, then it's basically a question comparing the footprint of our energy that we put into the grid to the grid average, for example, or comparing it to a solution that we might phase out by putting in more renewable energy. So that could be then one of the more fossil-based ones, being it coal, but still a heavy thing in Germany, for example. So that then depends a little bit on what you look at. And to the second part, a role of robotics. Yeah, I think So maybe a bit of history here, just briefly. Airborne wind energy as a technology was already been theorized about in 1980. There was a scientist who basically proposed that you can produce energy that way in a piper. But at the time, technology just wasn't ready from a materials perspective, from microelectronics, power electronics, and not at all from the software perspective. So the big challenge and where technological progress has enabled this now is basically that we have progressed enough that we can actually bring all these different new developments together and make the system work. So that's only something that has been enabled recently. And yeah, that's enabling us to build a better wind turbine in the end. That's what we're hoping for.
Fantastic, very interesting. Thank you so much for those reflections. I'd like to see if anybody else wanted to speak to this point about baselines and monitoring and incremental impacts in their respective application area.
Yeah, I can say a few words as well. So the specific area that we targeted is the erosion of blades, of course, which I went through. But the way that we try to make a baseline is actually developing in the sense that once you stop a wind turbine to repair it, you then basically, at least on a logical level, have to supplement the lack of energy being provided by fossil fuel. And the way that we calculate it now, and we are trying to bring in consultancy specialists on this, but the basic method is comparing fossil fuel energy of the downtime, lack of energy. And to that effect, we are calculating around 447 tons of CO2 per repair, because as humans, we take much more time and there's much more downtime, whereas robotics can do it faster. And it of course improves the longevity of the wind turbine, and it might improve the energy efficiency of the wind turbine, having the leading edge restored. But the downtime itself is more quantifiable. But whether you can compare it with fossil fuel directly, how the grid is set up, that is something that we're looking into to kind of bring a baseline to this aspect. All right.
Thank you very much. Elizabeth, did you have your mic off for a moment there?
I did. Yeah, no, I just wanted to kind of chime in briefly and just talk a little about, I think it's like interesting to think about incremental impacts versus just massive shifts in the way kind of things have been done. And so like thinking about our technology at TreeSwift, which is a new technology being applied beneath the canopy. When I think about how some of the utilities, the landowners that we're working with today are viewing this, it's essentially giving them an avenue and an access of information that has really not been able to be accessed previously at kind of a scale and speed. And so in terms of the what that really means for the climate problem is, forest management. I think all of us are aware of the massive wildfires that have been breaking out due to various things regarding forest management and proactive types of approaches and things that can be mitigated there. I think that what we're seeing is that this technology is really enabling arborists, foresters to see risks, before they kind of break out in these catastrophic types of scenarios, and where basically these carbon sinks are then released, and kind of all of that stored CO2 gets released into the atmosphere with wildfires. And so I think that one of the things that we're seeing is that with this technology, it's not so much like an incremental change, it's just like a fundamental massive paradigm shift about what is now available with robotics and AI leveled on top of that in order to get through the amount of data that we're kind of collecting and going through in order to detect kind of these risks before they break out into catastrophes.
Thank you, Elizabeth. That's very interesting and very on point, of course. Thank you for pointing out the huge gulf between incremental change versus, in this particular case, yes, indeed, a paradigm shift is definitely not hyperbole, right? It's appropriate to use that term. Lelyana, also going to turn to you in case you had an. Okay. Go ahead,
Yes,
please.
I'm trying to understand the question. So which concrete climate problems are we specifically prioritizing in our application of robotic, as we know that we want to tackle climate issue, right? The sea level rise is our concern. Using the drone, as we know that mangrove forests have been degraded over the past decades in a very, speeding scale. And the drone planting exists actually to help accelerating the process of restoration projects. But we also realize that the use of this technology has some limitations, since we are implementing on the ground that, the hand plantings, perhaps perform to be having a high level of success rate of growing in terms of the drones. So we are testing that in the field right now. So when it is not necessary, when laborers are available, we don't use the technology. We will work with the local people to restore the land. So the drone technology only used when it is necessary, when there is a dangerous crocodile, animals that we cannot plan with human labor. So that's probably where the drone application is very useful. So I'm saying here that, yeah, of course, the technology is important, but we have also to see the context, the local context, whether it is needed or not, because nature-based solution, in my opinion, is still I think the best approach. But combining the technology and local knowledge and local engagement would be very powerful for increasing the performance of whatever we want to tackle for these climate and planetary issues. So my take is, yeah, we don't want to cut the cake with chainsaw, so as much as possible we are trying to be useful and helpful to the people and the environment, not the other way around. So that's probably what I can add in this session. Thank you.
Thank you so much, Lelyana. I actually have a follow-up question, but I'll hold that until we pose our second question to the group. So I'm going to invite Jane to ask her question.
Thank you, Rinku. So for the next question, I'm very interested in what existing regulations for aerial robotics already support climate technology development in your cases, and what policy changes or wishes are needed to accelerate your applications. So I feel that everyone is aware that the climate problem is growing in a very fast scale. So I want to maybe call on first with Lelyana on her thoughts on this question.
Yes, thank you, Jen. Can you type the question so that I can read the questions?
Existing regulations that already support your
Yes,
technology?
I think there is one of that we are facing about the bureaucracy and about data authorization. Also, yeah, if you fly drones in some territories, like sensitive territories, we need some kind of permit. So that is probably the security and privacy issues that we are dealing. And yeah, the disturbances because of the drone activities, such as noise, for example, that can also affect the local ecosystem and, perhaps disrupt fragile habitats. So that is another issue that we are dealing. So yeah, so regulation definitely it's something that we need to deal with. Yeah, security and permit and the utilization, the objective of the use of the technology has to be clear from the start.
I see. Thank you. What about Elizabeth and her application in your application in your forest monitoring?
Yeah, so early on in TreeSwift, we actually started by moving our sensor through the forest with drones. Then we developed our signature backpack, in which the same sensor is on a backpack that a person wears as they hike. And now we're putting it on utility vehicles and trucks as well. For the drone application, I would echo many of the things that Lelyana kind of mentioned, and our experience with drones and regulations, I will say, is limited to use in the United States. So that's like our experience, but there were various FAA regulations that we had to navigate, in particular beyond visual line of sight. So operating drones where we, forests are oftentimes operating under 400 feet or flying under 400 feet. We were flying beneath the canopy primarily. So beyond visual line of sight waivers. But I think that the time to get those types of waivers has kind of been minimized since our experience in applying for that a few years ago now. But it is not a small task to get these types of waivers and kind of overcome this. And when you're thinking about deploying drones, as we were, across hundreds of acres, thousands of acres of forest land, you really need to ensure that the regulations allow it to scale. But then, as Lelyana mentioned, there are just areas that are very sensitive, such as if you're close to an Air Force base or other military base. Some areas you just can't fly, or it's very difficult to do that. So I would say that it's really specific. In terms of the improvements there, I would say that in a lot of these areas, in terms of forests, there are various habitats or other things that could be at risk, but I suppose that in the areas where there is minimal, lowest risk, being able to work with policymakers, get all of the stakeholders kind of together to help to move the needle on this. But I will say that is very operationally challenging when you're trying to scale the technology up to have these regulations there. So I think it's a matter of really having these conversations and engaging all of the stakeholders together to get into alignment. But it's just challenging. So I want to acknowledge that.
Yeah, I think it's very important for us to recognize the challenge that we're facing in deploying these technologies. Previously, I talked to Max and Frank about wind energy generation and how they had a recent win about German regulations. Do you want to add more about the policies and what changes would you like to see in the future?
Yeah, happy to. So the win that I mentioned was including airborne wind energy. So specifically, our technology niche, I say, within the German renewables law. So it's basically a recognized technology alongside conventional wind turbines, PV. What else is in there? Geothermal, biomass. So it just recognizes the technology for the first time actually in any German law. So that's very specific though, but it has much of a signaling as well, which we hope will unlock more research funding and will eventually trickle down to the European level, or trickle up rather. So that's the one thing. And the other, where it's much more about the actual airspace regulation, is the permit that we got. So it's a general operating permit for our type of system, and it is under the European new drone regulation, basically. So this is new regulation that basically covers the whole EASA airspace, so all of Europe plus some additional countries. And since we went through that in Germany, we're basically eligible for a whole EASA space. So this makes it simple, I say, to then transfer that to another country. So what you mentioned, Elizabeth, that it sometimes is really tricky with all the regulations in different countries. In that part, we hope it will be somewhat manageable. But that process to get there wasn't actually that easy. So we had to fill out the whole application. It took us 3/4 of a year now, with like 3-4 iterations with the authorities, plus writing operational manuals for the whole system that then take like 80-90 pages. So it is a lot of work that you need to do. And I mean, it's good that we have it now, but it's still not entirely sure yet whether that will actually be the way our technology will be regulated in terms of airspace eventually. Because we could still go the route, since we have since we're not a drone that's flying everywhere, but we are connected to a fixed ground station. We could still also be regarded similar to a conventional wind turbine as an obstacle in airspace. So where we're just basically putting a dot on airspace maps for planes to know, do not fly in there in these altitudes. So that would also work for us, but right now that was what we need to go after, because that's what the authorities told us. But yeah, it's a so-and-so.
Yeah, I can see like the implementation is after the policy has been passed, then the implementation is another tricky question to deal with. What about you, Frank? I would like to hear more about the maintenance problem, because this is common sense, right? It is a very obvious problem that we need to tackle with.
Yeah. From a commercial standpoint, we could always need regulations to support the way we want to do things. But in terms of how does regulation potentially hinder or support climate action in renewable energy and wind energy specifically, I think that the regulation change that we could see help out innovation would be in classifying some projects as an R&D. One thing is that when we work with big corporations, energy companies, they have the support, the back-end support to make these special operations risk assessment application that takes them 3 to 4 months. And that's the way of doing business that they're accustomed to. So it doesn't really affect their progress in climate action per se, but bringing them the tech disruptions, the innovation that they need to source externally. We have to follow the same rules through and during the R&D phase, which is a problem for a small company. And you typically want to locate your company to attract the best talents. And although that's not necessarily near an airport or a sensitive area, it is probably somewhat urban, potentially a bit rural, but the new regulations state that you need to be 150 meters away from buildings, which isn't, a hard problem to solve, but it does hinder the way that we operate in the R&D phase. It makes planning and R&D and testing more, a structured approach, an issue. So I guess regulation could potentially introduce an R&D state for drones where you were granted more freedom, especially for smaller companies. All right.
Yeah, that makes sense. It's like a leeway phase or an allowance that you give to commercial or industrial companies who want to push a disruptive technology, never been tested in a scale that we want to. And then having that investigations and experiments with more, how would you say, less restriction policies or regulations. Thank you so much for everyone in this conversation. I would like to ask Rinku for the last question in our panel.
Thank you, Jane. And again, thanks everyone for really interesting responses to the previous questions. I'm going to type my question in chat first. And apologies, it looks very long. It doesn't have to be so long. It really sort of depends on your particular application area. So it is broadly worded. But overarchingly, my kind of main question in concluding is to maybe circle back to the question of application areas and local relevance, local clients, local, targets for outreach or stakeholders. So my question is, is there benefit to actually co-producing robotic science, climate robotic science and tech with relevant stakeholders, and as opposed to outreach and just handing over a tool or handing over a data set, right? So is there benefit to actually co-developing these technologies jointly? And if the answer to that is a yes, perhaps, or yes, partly, then the second question is recognizing that oftentimes, even at a local site, we're dealing with lots of different kinds of stakeholder groups who may have very different forms of local knowledge and priorities. So the example of mangrove planting comes to mind, right? Lelyana, you mentioned sort of the relevance of local labor and local knowledge in that context. And local knowledge is not a unitary thing. There might be different forms of it. What might be some challenges or benefits you have faced or you envision in actually working with a diversity of different sorts of stakeholder groups with different knowledges and different priorities? So again, pardon me for the kind of rather big, broad question, but feel free to narrow it down as you see fit. So, and maybe I can call on Lelyana perhaps to offer some initial thoughts. It does loop into one of your responses, Lelyana, to the previous question I had asked.
Yes, thank you. So your question, is there a benefit to co-producing climate robotics science? And this is very long.
You can take either part of the question as you see relevant also. So is there benefit to co-developing, for example, the drone planting technology or its particular, maybe calibration exercises and so on and so forth with local community members, for example, in your case? Or do you have thoughts on, the particular kinds of stakeholder groups that are most relevant, and maybe other stakeholder groups that could also be relevant? And how do you actually decide whom to work with, and what are some challenges in that regard?
Yes, based on our experience in the field, working with these different groups of stakeholders with different interests, I guess bringing them all together is the key. So the different stakeholders in the field, be it the local communities, local authorities, local NGOs, and so on and so forth, they have to work hand in hand together in a partnership. So that is the key. We thought that there will be successful project going to happen, in my opinion. And about the co-producing, about technology, I think in my point of view, we need to hear more the local needs. So we have to see the technology development from the point of view of the local needs. So if whether or not this technology is needed, so that we are not developing something that is actually not going to be useful or needed for tackling different kind of issues, especially people's and livelihoods, that's something that is relevant to that. So apart from the climates, but I did have an experience working for a technology company where technology actually is being very useful, For example, I work for this pipeline for gas and oil companies inspections, where the robot there is investigating the leakage or corrosion that is happening within the pipelines. So in that sense, the robots or technology device is sensor. So I work for ultrasonic devices. So then it is very useful because, you know, when you have some kind of damage in the pipeline, it will also influence to the environment and the security of the people living nearby. So in that sense, it is needed to have this robot inspecting the pipeline. So I think all this technology development depends on the need. So we have to hear the voice from the ground. So what is actually needed, and then we build that on the basis of that. I think that is perhaps my opinion on, yes, how local knowledge is very important, and it is very priority, and that is the voice that we need to hear, so that our technology development is, you know, actually helping, so harmoniously, you know, being useful for the people. Yes, thank you, Rinku.
Thanks very much, Lelyana. Any of our other speakers want to chime in on this question?
Yeah, I'll add, so I think that just in terms of the technology development, the co-development, it's very important to have the alignment of key stakeholders, and to kind of just building something kind of in a vacuum and then handing it off, I think is, you know, it's a bit, you know, it doesn't really give you a sense of what you're building is actually useful, kind of as what Lelyana was saying. And so I think what's been really important, at least in TreeSwift's journey, is to bring along the landowners, the managers, the end users, various groups who do forest measurements today. It's a whole profession and called timber cruising, where people go out and take these measurements by hand. But bringing in these different voices and perspectives, and as a technologist, it's really making sure that these folks are along on the journey and really listening to their voice as we go on and create this technology, to ensure that we're really maximizing the impact that it can have, and really ensuring that we're applying the right technology, or making sure that, you know, we listen to these voices in terms of any pivots that we might need to make it more useful, more impactful. So I would say that, you know, especially in the early stages of bringing a technology, bringing robotics, really hard technology to affect kind of climate impact, it's just very important to have the alignment of all of the stakeholders in order to ensuring, you know, what you're building has the maximum impact.
Hey, thank you so much. Actually, Max, did you have a comment? Please feel free.
I can add a little, but don't need to if we're running out of time or anything.
No, we have time for a quick comment. We would love to hear your reflection on this.
Right. Yeah, so I think I would totally agree with what Elizabeth said in regards to listening to the customer that you're building for, and early on trying to understand what is important to them. So that's definitely something that we do as well in building our product. On a different note, though, since what we're building is a totally new type of system, there's limits to that. So because there's just some stuff that where we basically only have the understanding or the tests or whatnot to actually bring that solution to where it needs to go. That said, we are very aware of like constraints that come with that. So especially in wind power, people are bothered by having something visible in the sky, are bothered by noise, want to reduce impact on birds, for example. So these are all things that we take into account, but the core development is still something that very narrowly happens at KiteKraft, with collaboration with a lot of universities, for example. So we are collaborating in research projects in the wider scientific community that's happening. But then for local stakeholders, it does become a little bit different when we're actually at a stage when we're actually deploying systems, because when we're starting with 100 kilowatt, it's a rather small system. And if we're talking, for example, about the microgrid market, which is a pretty distributed one, in especially it's big in the US, but also in the let's say global South, South America, Southeast Asia, island grids. These are all harder to reach places for us as a company, and especially as a small company. So that's where we then want to work with local stakeholders and work with microgrid developers who have the experience in the country. They have their own workforce there. So we basically provide training then down the line to actually maintain our systems, operate our systems, rather than doing all that ourselves, but just finding networks that we can tap into and just making it bigger, faster. That would be an aligned goal then that I can think of.
Thank you, Max, for that insight. It's really important to have this collaboration between different stakeholders in our revolution for climate for climate endeavors. Just a quick note, Mr. Yohan Hadji for weather data collection in the stratosphere just joined us, and we would like to acknowledge him and would like to ask him for this time to introduce himself and maybe pitch into the previous questions that we have asked the speakers today. Yohan?
Yeah, thanks a lot. I'm super sorry for being that late. I'm actually extremely late on the preparation of a test flight of one of our systems that we're going to fly tomorrow early in the morning. So quick context about what we're doing. Basically, I'm not sure you know exactly how we get weather predictions as of today, but it requires launching a lot of single-use atmospheric sensors, which are called radiosondes that are attached under large helium balloons. And what we're trying to do is to use gliders, may they be like paragliders or fixed-wing gliders, like I have in front of me. But if I move my computer, everything will break, so I will not do that. To try to guide those sensors back to precise landing points, ideally the launch site of the balloon, to make sure that we can reuse the same hardware, the same sensors again and again. And the final vision, the final goal is that if those systems are working pretty well, we could collect much more atmospheric data. And the moment you have much more atmospheric data, and potentially we'll have tomorrow someone from Robotics, which is another Swiss company doing weather prediction with more data, talking about that. Tomorrow, the moment you have more data, then there's hope to improve weather forecast, which ultimately impact almost everyone on Earth. So I think that the questions in general are going around the idea of like, are we actually sure that the robotics stuff that we use on those climate questions is useful and not bringing more harm than value? And this is really a question I've personally been asking myself quite a lot in the past years, like am I actually doing something that's valuable, or am I just another robotic project that's using climate as an excuse to do something cool? And for a long time I wasn't really sure, but actually the moment you finally see the technology working and technically bringing hardware back to a launch site, while this hardware was initially supposed to end up in nature and be just trash, there's a switch, and all of a sudden I'm much more convinced that robotic solution can actually help and be beneficial and bring more value than harm. But I think that we all have to be super careful, because it's quite easy to convince yourself that something is valuable when you spend all your day thinking about it. So I think that in general, sharing ideas and participating to event like that, and being able to get feedback from someone who's also trying to use robotics for cool applications, and maybe getting those critical feedbacks of like, are you actually sure that the thing that you are trying to do actually helps, is always super cool. One of the challenge with this project is also that we're trying to fly robots at 20-kilometer altitude, 30-kilometer altitude, and last year there was a lot of stuff in the press about balloons flying at those altitudes, and the concerns over like regulation. Can any country fly robots at super high altitude above another country? One of the really cool thing with the specific application of robotics that we have is that technically you could say that what we're doing is flying drones at 20-kilometer or 30-kilometer altitude, but we found a way to actually get those gliders not considered as drones, because today drones regulation are quite strict. So I think this is a challenge for AI robotics in general. Like the technology doesn't only have to work, doesn't only have to reduce the impact of something, it also have to be permitted to fly. Otherwise, it will just be useless, because no one will be able to use it, because the amount of energy that will have to be spent onto regulatory aspects will be just way too much. So in the specific case of our project, we're kind of also hoping that this can continue like that, and in a way that there's a way to shape regulations to make sure that more environmental friendly solutions are not being restricted just because they look like drones, while in the end they could make the world a better place for everyone. So I think this is quite important. And I think I've already been talking too much, so I'm interested to hear what you also all think about. And if you have any question, I'm happy to try to answer them.
Thank you so much, Yohan, and welcome to this discussion. I would like to ask actually Frank, since you're dealing with maintenance of these technologies, do you have any specific question to Yohan regarding his the project that he has been talking about?
I'm not sure I have as much a question than a fellow understanding of some of the feelings that you represented about how do you view your own project that you can be consumed about. And that also speaks into the previous question about having stakeholders to kind of validate and confirm your own perception, and also on a human level connecting with someone, seeing the value of it. So I feel with you, Yohan, and I just want to say keep troopering on. It's a joint experience. We all know it. So yeah, and not as much a question, Jen, but a support to the human experience of being an entrepreneur.
It's beautiful to see you interact, having different expertise and having the same goal of helping the earth and climate. Any other speakers who want to pitch in before we move on to our next question? All right, so I'll take it as no. Let's close with our final question, which is quite broad and interesting. So we would like to ask every speaker, how can the climate robotics community support you? So in terms of, are you hiring, or are you launching new projects in other countries or in your own country? Are you seeking funding? How can we help as a community? Let's first call on maybe Elizabeth or Max.
I'm just pulling up our careers page so that I can put a link in the chat here. So I really love this question. I think that just speaking to some of the remarks that Yohan gave and Frank gave. I think that, this type of format really allows us to solidify connections, and just, I also think that many of the things Yohan remarked on resonate with me as well as an entrepreneur. But in terms of the community and kind of the support we're looking for, TreeSwift is hiring. In particular, we're hiring for a machine learning and computer vision software engineer. The position is based in New York. So would really appreciate the circulation of kind of that position, or any leads that you could throw our way. And also just in terms of, I think one of the questions in this, or the prompts, launching projects in other countries. TreeSwift does have our first project abroad. It's close to our home base, but it is abroad, and so we are currently kind of navigating various things that involve operations in a new place. And so if folks are experienced in that, or have any perspectives to share in kind of going to a first international project, in particular, just navigating various things about putting our technology into a new country and working with local stakeholders there, would appreciate any DMs and messages my way.
Thank you so much, Elizabeth. So if you have any leads, please reach out to Miss Elizabeth. Next, Mr. Max.
Yeah, on hiring, we have 2 working student positions open, so that's the only thing I can offer in that regard, and it will be Munich. So if you know anybody here, let me know. On the customer perspective, we do have a couple of folks that we have letters of intent with, negotiating for a potential pilot project. But we're obviously always interested to hear about more folks that are interested in our solution. So specifically connections in the microgrid area, microgrid developers in countries that we maybe are not so familiar with. Any connections here would definitely be helpful. And then we actually do plan to fundraise this year as well, a little later in the year. But if that should be interesting to some of you or somebody you know, share the word. Thank you.
Thank you, Max. It's what about Miss Lelyana, please?
Yes, yes. Thank you, Jen. How the climate robotic community support us is by keeping up to date with technological trends and acting as medium for open discussion on the pros and cons of using the technology to tackle the current planetary crisis. So network connections, that's always helpful. And in terms of hiring, I'm not the co-founder or the CEO, but I heard from the CTO we might have a position later this year. So reach out if you think you want to be involved in restoring mangrove. And yeah, we are currently working in Indonesia. So if you know some companies who take so many natural resources and want to bring back positive impact to nature and want to plant mangrove in Indonesia, please do contact me. So I am welcome to links and information for, because we are preaching the corporates actually to bring impact on the ground. So we are preaching the corporations. So if you know any kind of companies willing to plant mangrove in Indonesia, just please contact me. Thank you very much, Jane.
Thank you so much, Miss Lelyana. I would like to call Frank.
Sure. I think it's great that we all, try to help the climate, and we're not even competitors for let's say engineers for positions, because we're in different locations. So you can actually look at it as a way to offer your current employees a way to transition in their career to more or perhaps equally exciting places in the world. It's nice to recommend to engineers that you meet that you know about the companies, and we also look for engineers, and we hire globally. And I think that's one of the advantages that we have as climate action or climate oriented companies. Even though we don't have a brand, I'm not saying all the other companies you don't, but we don't have a brand. We're a small company, 10 employees. So the people that, Denmark is a small country, 5 million people. And we can't really hire the experts that we need, because we also do stuff for the first time, like world's first. Like you said, Max, about your technology, right? It's new and it's innovative. So you can't necessarily find someone who has 20 years of specific experience, but you can find someone who's in the domain, who's a domain expert. And in Denmark, they would typically not be within 45 kilometers of range, which is what the average employee is willing to drive. But having a climate tech, having robotics, that draws people from all over the world. We've hired from Ukraine, Russia, India, Malaysia, UK, and they uproot themselves. They relocate. They come to Denmark, of all countries in the world. And no offense to my fellow Danes. And I think that's really nice. So even though I heard a lot of you others also, needing 5, 4, 7 engineers, employees, what you need. I think it's compared to your run-of-the-mill company, if such a company or if an Anoman exists. But I talk to a lot of owners and founders of more perhaps regular industry companies, and they can't even attract one employee for the last 3 positions. We're lucky enough without a brand to attract, which isn't much, I know, but for us, 30, 40, even 70 applicants sometimes for the project. And that back to what you talked about, Yohan, about being a bit distraught with yourself, not being able to self-assess if you're doing something. Again, for such a small company to see people being cheerful and want to help out and kind of have the energy and vibe around them that you also have, that they want to do something that is, well, perhaps not special, but makes a bit more meaning than making pumps at a aqua company. Producing new pipes and I don't know, we're not temperature sensors, not that there's anything wrong with temperature sensors, and that's not what I'm getting at. But once the climate part becomes a part of it, it's just nice. So yes, we're also looking for applicants, which you can go to the REBLADE LinkedIn page. And then we are finalizing a financing round, an equity round in the coming month or so. So yes, we're open for that. But other than that, I think you're already doing it in terms of helping us whenever we all get to raising equity capital, if we do, because when you put focus on to put it perhaps a bit ugly, the political correctness, not just the pure necessity and logic of climate action, you also make it more interesting on a human level. You want to be part of something as well, just as the candidates that we have for job positions. As an investor, when you look at companies like this, the capex, the money that needs to be spent to make something like this, finalize its development cycle and then scale it, why would they not look at something that's more SaaS oriented? And I think such a thing as this summit, it also helps to get the message out that feel good about your investment and invest in climate. So thank you. That's it.
Thank you, Frank. And quickly, Yohan?
Yeah, well, I'll be very quick. So basically, at some point, we'll have to go in almost every country of the world and get permission again to fly our system in those countries, or at least hope they are also classified as not drones. And I'm sure you are all flying drones in all countries, and so have good contacts with the CAAs in those countries. So we'll be super happy to get those contacts and talk with the right people in those countries to get permission to fly our gliders. That's it.
Thank you so much for this community. All of our speakers, we are very grateful. With Rinku, we're so honored to be here, and it's great to see solidifying connections in this climate robotics community. And we just want to to wish you all a good day. And hopefully this technology enables us to connect better and help the climate, help us in our climate goals. Thank you so much.